السلام عليكم ورحمة الله وبركاته. حياكم الله جميعا. معكم خالد العيسى. Our project is Riyadh Walkability. Our project team is Abdulaziz Al-Anizi, Khalid Al-Isa, Nadis Shamlani, and Rana Al-Yahya. Part of Vision 2030 goals is to increase physical activity among adults in Saudi Arabia. And there are many related events such as Sport for All Federation and humanizing districts of Riyadh. So we build on that by trying to identify walkable options in Riyadh city per district and suggesting ways to improve them. For our scope, we decide only to use aerial images and map layers provided by GEOSA and nothing more, so we don't have specific cost to our project. And we follow an incremental approach. We understand walkability is a wide topic and we focus on simple criteria. So our criteria is street assessment, sidewalk assessment, distance to malls, and available parks for every district, which we are going to talk about. This is our flow chart of activities that have been done to perform this project. So this is one of the steps, which is segmentation using a SAM model to identify pavements from an aerial image. We used New York City data since we didn't have access to Riyadh aerial image. So this represents the pavements of New York City. The results that we obtained are sufficient to perform our analysis. So for calculating the street score, we started with the polygons representing sidewalks, and we have the street data of New York. So we casted perpendicular lines coming from the center line of the street, and then we calculated the intersections. We collected the intersections with every pavement polygon, and then we took the median of that. And that resulted in a clean map of the streets of New York, as you can see here. This is the next step which we did. We are only interested in car density in the curb lines, not in the main line. So we segmented only the curb lines in order to calculate the density. We also make use of a refuge line. We define the refuge line as the line where if you pass by a car, you have to step aside to some refuge area. So this is important, especially if there is no pavement and there is no curb lane to walk on. For our scoring formula, we use the curb, and we use the availability of refuge on the street to calculate scoring. Similarly, for calculating the sidewalk score, we used a similar formula, but for this time we use the start and end of the start intersection and end intersection. Then we calculate the median for each, and that represented in clean representation of sidewalks in the area covered by the aerial image. For the scoring formula, we use a simpler formula where we use the sidewalk width. So if it's 2 meters or more, they are considered good, with every additional meter considered as 20% better. Here we show the distance of the distance between districts and the nearest mall. Malls are considered one of the most suitable areas for walking activity in Riyadh, and are especially useful in summer, in hot summer and cold winter. Similarly, here we try to find the parks in Riyadh city, which are also suitable for walking. We collected that data from OSM, which is not representative of every park available in Riyadh. So we have, in future, we can complement this with manual collection or AI detection model. So for the results for New York City, as you can see here, the street data. New York City streets are not made for walking. So as you can see, some streets have higher car densities and lower walkability scores. On the other side, sidewalks are almost always good based on our scoring formula. And here, like we mentioned before, the distance of each district to the nearest mall and the parks available in Riyadh. Uh, so our future plans, uh, we plan to take more data from existing GEOSA products, such as digital surface models, to enrich our scoring approach, to consider things like street elevation, pavement elevation, and shading in the area from nearby buildings. And we plan in general to increase the number of criteria used to assess the streets. Here is one example to include noise pollution in scoring of walkable in walking experiences. As you can see, we tried to use an unsupervised machine learning concept in order to detect the places where there is a high density of cars, which helps in detecting noise areas. And we have seen positive results here. We also attempt to use YOLO for tree and obstacle detection, which we can use to enhance the sidewalk assessment by detecting obstacles on the street and detecting shades on the sidewalk. That was our presentation. Thank you. Now we move to the demo.
Assalamu alaikum. My name is Prince Farhan, and I will be giving an overview and a brief tour on the dashboard. So as you can see, we have two main components: the chatbot that interacts with the map. The map here, uh, for the front end, we use actually React, and for the map, we use DickGL for its fast performance in showing spatial visualization. So you can see the module we use here is a local module called Liquid AI, and it's a tiny model, only 1 billion parameter. So an example of the things that it can do, mostly the LLM interact with the map through a neighborhood data. So you could see here it's saying that there is only 7 neighborhoods that it's the walkability score is more than 75. And then we could also, for example, say show me a combination of neighborhoods on the map as the polygons, and it shows the location and the area of those neighborhoods. Even if we say it in Arabic, it still get the idea. So you could reason with the data through the LLM, and it has doubled the polygons. We could also use it to show some charts here. It shows us charts about the data that we have. Also, one last thing I would be saying, that it also can interact with the layers. So if I say show me the walkability layer, it should show me the hexagons that we use for this demonstration. So that's it for the demo. I hope you liked it, and thank you for listening.